This is the power of a power, and it's usually called index law number 3. And what we have firstly to see and discover how it works is to look at this little task we have here, and we've got use the expanded form of 5 cubed, 5 to the power 3, to simplify this unruly beast, 5 cubed all squared. Ooh. Well, first thing we can do is work on this here, and basically that there is expanded out here, 5 cubed. Well, that part's easy, isn't it? So 5 cubed is 5 multiplied by itself, done 3 times. Okay, that bit makes sense. Now the squared bit comes in when we look at what is something squared. Something squared is something by itself. Okay, if we go back to the easiest one, x squared is x times x. So as you know, something squared is something times itself. Now we just had something there, we just had that. That is something. That is one term. And we are now timesing it by itself. Can you see that? It's the same thing. And so there it is. Okay, there's one thing and another thing times together. Alright, now that equals 5 to the what? What's going to go here in this square? Well, remember the index tells us how many of those 5s there are. So we just simply count them. 1, 2, 3, 4, 5, 6. So it's 5 to the power 6. So we'll write that in there, 5 to the power 6. Okay, so if we repeat the same steps above for these two here, we've got 2 more to do. First one is in yellow, and it's 3 squared all raised to the power 4. Notice how I say that, 3 squared all raised to the power 4. So let's do that one first. So 3 squared all raised to the power 4. Let's expand that out. So first thing I'm going to look at is the 3 squared part. So inside the brackets here. Okay, we're going to put that there. And what is 3 squared? Well, 3 squared is expanded is 3 times 3. Alright, what have we got to do? We've got to replicate that 4 times overall. So we've got 1 there. So we need to times it by another 3 by 3. That's 2. Another 3 by 3. That's 3. And another 3 by 3, which makes 4 all up. Okay, so we've got 1, 2, 3, 4, and that's where the 4 comes from. Okay, and we've got to put in, like we did last time, the final answer. Well, it's going to be 3 raised to something. What's going to go as the index? So we count them up. 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, did you note something there? 3 times 2 is 6. So 3 times 2 is 6. Oh, you can't see it anymore. But 3 times 2 is 6. Let me write that in there. And 2 times 4 is 8. There seems to be a pattern there. And there is. And we'll formalise that in just a minute. We've got one more to do. Let's see if it works out the same way. X to the 4 all squared. X to the 4 all times the power 2. Okay, let's do that one. So we've got x to the 1, 2, 3, 4. There's 1. Let's put that there. That's 1. And then we've got the second one beside it times, have to move to the right, 1, 2, 3, 4. Okay, so, and that's the second one. And we can simplify that. That's x to the what? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 8. Did you note that 4 times 2 is 8? So there is a pattern here, isn't there? If we multiply the indices together, we get the resulting index for the answer. And that, people, is what we call the power of a power. So the power of a power is commonly called index law 3, and this is it here. So we have a to the m all raised to the power n, that equals a to the m times an n. So basically we keep the same base, so we retain the base and we multiply the indices, okay? And there's an example there. 2 by 3 is 6, so x squared all to the power 3 is x to the 2 by 3, which is x to the 6. That's index law number 3. Very quick, two very quick examples. Okay, so the first one is very straightforward, and we've got down here x to the 5th all to the 4th, which is x to the 5 times 4, which is x to the 20. Boy oh boy, that saves a lot of work compared to expanding it out. Imagine if we had 20 x's all multiplied together. Good grief. So that saves a lot of work, doesn't it? And be careful. B for be careful. Be careful. Alright, look, it's only the y to the 5th in the brackets. So this little index here only works on what's in the brackets. It does not work on the 2 outside there. Alright, so the 3 outside there. The 3 is separate, so there's like a wall there, and this 2 only operates on the y to the 5th. So be careful. It's a power of. So we've got 3 times y to the 5 times 2. Okay, so we've got 5 times 2 there equals 3 times y to the 10, which equals 3y to the power 10. Try some powers of the power.